The next topic is addition and subtraction of algebraic fractions. Abbreviation is LCD. Then work must be done to determine the lowest common denominator before we can proceed. The procedure to obtain the LCD is the same as in numerical fractions. The procedure then to obtain the LCD will be explained now. First, factor the denominators of each fraction. Also, factor the numerator to see if any reduction of the fraction is possible. That would be a wise thing to do at the very beginning. Factor the numerator for possible reduction of the fraction. Having done that, the next step is to build the LCD, and be very careful here. We'll refer to this as the LCD builder. The development of the LCD builder is accomplished as follows. Every factor of the first fraction is part of the LCD. Now, in the remaining fractions, taking them one at a time, select those factors from the denominators that have not yet been listed in the LCD builder. In the remaining fractions, check each denominator separately and place in the LCD builder those factors which are not already present. Now, having established the lowest common denominator, do not multiply these factors out. Leave the LCD in factored form. Once you have the lowest common denominator, the point is that each fraction must be converted to another equivalent fraction with the same denominator. So each fraction must be rewritten with the LCD. Divide the denominator of the given fraction, the original one. Divide that denominator of the given fraction into the result will be a quotient or another factor. Sometimes if you divide a given denominator and the LCD happens to be the same denominator, you might get 1 out of it. That occasionally happens. But nevertheless, when you divide the denominator of the given fraction into the LCD, you will end up with a factor of some sort. Now this factor, this answer, a quotient if you like, will be used as the multiplier to increase the numerator the appropriate amount that will result into an equivalent fraction. And the factor resulting from the operation is used as a multiplier on the numerator to obtain the equivalent fraction. You must do this to each fraction given in the original problem. Finally, add and subtract like terms in the numerator. Leave the denominator factored. Don't attempt to multiply out the factors there. It's customary simply to leave the factors as they were first found. We'll deal with a simple example first. Take 3 over ax and subtract x over 2a squared followed by minus 7 over 2x. But check the factors of each of the factors are for ax, well, that's fairly obvious. It's a times x. In the next denominator, the factors are 2 times a times a, and that's fairly obvious as well, and finally 2x. Over on the side, we will develop our LCD builder. Recall that the first set of factors of the first fraction in the denominator are always members of the LCD builder, and we simply write ax immediately. The next denominator has factors 2, a, and a. check the LCD builder. What factors over here are not already in the LCD builder? What factors from 2AA are not already there? Well, the 2 is not already there. Neither is that second A there. We have one A, but we don't have the other one. And so, as I explained, are there any factors from this fraction that are not already there? The answer is no, because we have a 2 and we have an x, so we don't have to attach those factors to the LCD builder. Lowest common denominator, and that is 2 times a squared x. So now, we must take each of these fractions and change them into equivalent fractions with the new denominators. And this is how the procedure continues. Take the lowest common denominator, divide it by ax, and that is equal to 2a. You take 2a and multiply it by 3 in order to get the new denominator, the equivalent fraction with the new denominator. In other words, with this work completed, we can do the following. 3 over ax is equal to 2a squared x in the denominator and 3 times 2a. 3ax becomes 3 times this over that, and we have an equivalent fraction. 6a over 2a squared x. The next one is 2a squared, so we begin and say 2a squared x divided by 2a squared, check it, equals x. So the next fraction, x over 2a squared, will have a new denominator, 2a squared x, and this x will be multiplied by this quotient. Consequently, the new equivalent fraction is x squared over 2a squared x. And finally, in the last fraction, we begin with 2a squared x and divide by 2x. The lowest common denominator divided by the original denominator results in a quotient, a squared, or a factor if you like, which is then used as a multiplier to increase the numerator of the original fraction in order to get an equivalent fraction. So this is changed to the new denominator, and 7 is multiplied by a squared. That is then equal to 7a squared over 2a squared x. There you have every one of the given fractions changed to their equivalent fraction, but the denominators in each case are the same. We can now continue and add this up. We can write the denominator once, since the denominator is shared by all of the fractions. And on top we have the sum 6a minus, because there's a minus sign there, be careful, minus 7a squared. In the next example, I have 2b over a minus b added to 2a over b minus a. Now recall working with binomial factors that look like this, where the terms are the same except that the terms are turned around, so to speak. So we will write 2b over a minus b, subtract 2a over a minus b. Since the denominators are the same for these two fractions, we'll write the denominator once since they both share the same. We end up then with 2b minus 2a. Be careful with this one. It's sort of a trap. If you look at 2b minus 2a, you should immediately notice that 2 is a common factor, and we can factor it 2b minus a over a minus b. Well, look at this again. It looks like we have the same terms except turned around. Let's introduce a negative sign in the numerator to compensate for the switch in terms. Since we have a matching pair of binomial factors in the numerator and denominator, we can reduce that. And it turns out that this is equal to simply minus 2. It's certainly a more desirable. In another example, have 2x over x minus 2 and add 5x over x plus 2. If you look at the denominators of each of the fractions, you see that they are different. X minus 2 is not the same as x plus 2. In the LCD builder, which will result in a fairly simple result, x minus 2 is certainly going to be a member of it. X plus 2 is not part of the LCD yet, so it must be, and so x plus 2 will be placed beside the one I already have. And there is the LCD. So we now go about it in the following way. Simply write x minus 2 the one time in the denominator. Take x minus 2, the original fraction, and its denominator. Take it and divide it into the LCD. So now x plus 2 is the quotient which is used as the multiplier to change the numerator. So I would write 2x first, followed by the x plus 2 on the right, or simply extend the line and use the same denominator here, since of course both fractions now share the same denominator. Take the original fraction and its denominator, divide it into the LCD. Dividing will give you a quotient, which is the factor x minus 2, isn't it? So now x minus 2 is used as a multiplier to increase the 5x, the numerator, by an appropriate amount to give us an equivalent fraction. And we express that as an indicated product. You see, 5x times x minus 2. It's best to do it this way, and then write out the product by expanding the expression, so that 2x times x plus 2 amounts to 2x squared plus 4x over here plus 5x squared minus 10x. There are several like terms there, which you have to look after now. 5x squared and 2x squared is equal to 7x squared. So we'll write 7x squared plus 4x minus 10x is minus 6x upon x minus 2 times x plus 2. We can take another step here and factor 7x squared minus 6x as x times 7x minus 6 to see if there's any possible way that we can reduce the fraction, but you can see that. Another example, 2a minus 3 over a squared minus 25, and we have minus 7 over 5a 25. The first step is to factor the denominator. Let us write the solution to this in as compact form as possible. Simply show the factors under the denominator like this: a minus 5, a plus 5. Over here I have 5 followed by a minus 5. From the factored denominators, begin the construction of the LCD builder as I have referred to it. The denominators of the fraction, the factors of the first fraction are automatically members of the LCD, so there they are. Go to the next fraction and, checking its denominator, include the ones from it that are not already here in the LCD builder. Well, this factor 5 is not part of the LCD builder yet, so, and a minus 5 is, so we ignore that one and write 5 in front of it in that fashion. Now, I will write an equal sign and a long line under which I will write the lowest common denominator, and it will be shared by both of those fractions. The next step is divide those factors into the lowest common denominator. And it'll be used as a multiplier to increase to a minus 3. Similarly, take the other one and divide it into the LCD, and it'd be a plus 5. And a plus 5 is multiplied by minus 7. Now expand the numerator, and we have 10a minus 15 minus 7a minus 35 over 5 times a minus 5 times a plus 5. It'll take one more step because we can simplify the numerator by collecting like terms. That's 3a. And this is minus 50. 5 times a minus 5 times a plus 5. And that's the result. The next topic is on complex algebraic fractions.